Good afternoon. I'm discussing about liquefaction of gases. The gas it changes into liquid as the liquefaction of the gases. Principle of liquefaction gases: gas must be at or below its critical temperature for its liquefaction. Greater the critical temperature, easier would be the liquefaction of gases and vice versa. The gas is cooled either by doing some external work by it or by expanding the gases from its higher pressure region to a lower pressure region. Cooling of gas is usually accompanied by compression for liquefaction. Lower temperature is attained by any of the flow methods by using the freezing mixture. Freezing mixture usually consists solid having the low melting point of liquid having the low boiling point mixed with some other substances which modulate the temperature. Solid carbon dioxide or other volatile solvent, ice mixed with the salts are frequently used freezing mixture. These are the examples of the ice and water mix, ice calcium chloride, ice sodium chloride, dry ice tannitol, dry ice acetone. When the salt is added into the ice, the depression of the freezing point takes place. In fact, melting point of ice and the dissolution of salt both have the endothermic process and results into low temperature by rapid evaporation of volatile solvent. Lower temperature attained by using freezing mixture and rapid evaporation of volatiles. Techniques use the liquefaction of the gas. Faraday's method 1823. Faraday's method developed by the Michael Faraday 1823 is the one of the early methods for liquefying the gases. In this method, Faraday used the high pressure and the low temperature to condense into liquids. In this Faraday's apparatus. Sealing the gas, Faraday placed the gases in the sealed tubes, which allowed them to the pressurize. Applying the pressure, he applied high pressure to the gas, which pushed the molecules closer together and increasing their chance of condensing. Cooling, he simultaneously cooled the gas by immersing the tubes in a freezing mixture of ice and salt. Lowering the temperature reduced the kinetic energy of the molecules, making it easier for them to condense. With a combination of high pressure, low temperature gases like chlorine and ammonia were successfully converted into liquids that caused the liquefied under the right condition. Faraday's method. In the Faraday's method, the liquefaction of gases B.Sc tube in which the liquefied was prepared at the limb while the another limb was exposed to the freezing mixture of the ice with the salts of the cooling of the gases. The melting ice of the dissolution salt accompanied by the absorption of heat. Due to this, the temperature of the gases can always and lead to the liquefaction. By this method, gases such as sulfur dioxide, carbon dioxide, nitric oxide, chlorine, whose critical temperature are near to room temperature or above, can be liquefied. Uh, Second method, Lindy's method. In the Lindy's method, liquefaction is based on the Joule-Thomson effect. The Thomson effect is defined as the when the gas are allowed to expand from high pressure region to the low pressure region or vacuum under adiabatic condition, the cooling of the gas takes place. And in this process is based on Joule-Thomson effect. The pure gas is compressed to the 200 atmospheric and pass through the water-cooled pipe to remove the heat of the compression. It is then passed into a spiral pipe having the jet at the end. Through the jet, the gas expands out into the region of the low pressure In this process, it gets cooled by the Joule-Thomson effect. This cooled gas is passes over spiral, thereby externally cooling the incoming compressed gas in its return to the compression pump. Repetition of this cycle liquefy the gas. Claude's method. In Claude's process, for the liquefaction of the gas, the required low temperature is produced by allowing the gas to perform the mechanical work in the adiabatic expansion engine to expand adiabatically through the narrow jet into a region of the low pressure. Below its inversion temperature, in both cases, cooling occurs because some of the work is done by the gas overcoming the intermolecular attraction and the cost of the kinetic energy of the molecule. Uh, in the Claude's methods, when the gas is allowed to expand against external pressure under the adiabatic condition, the gas has to work against the external pressure. Since the process is adiabatic, no heat is lost or gained by the system. This caused the decrease in the temperature of the gas. It can say that work is done at the expense of internal energy of the gas, which result into fall into temperature. Claude in 1905 applied the principle with the combination of Joule-Thomson effect or liquefaction gas. Thanks for watching. Thank you for your patience. That's now. Bye bye. See you again.